inverse and joint variation today, and you've already learned direct variation if you kind of want to think back to that. So direct variation is when you have y equals ax. So you have that constant a that you usually need to solve for, and direct variation doesn't have a plus or minus anything. It's always going to be 0 there. So inverse variation, instead of multiplying your constant of variation by x, you're going to divide by x. Regardless, you always are going to start your equation y equals a. So then you can either multiply by x if it's direct, or divide by x if it's inverse. And again, the a is that constant of variation. So let's look at these examples, and we're going to see if they are direct variation, inverse variation, or another. So the first thing I'm going to do in part A is solve for y. So I'm going to divide both sides by x. Now I can see I have my constant of variation divided by x, so this is inverse. On the next one, it looks like this setup is really good for direct variation, where that constant of variation is 1. However, I have this plus 3 at the end, so in this case it makes it neither. Okay, again in part C, I'm going to solve for y before I do anything. So I'm going to multiply both sides by 4. And now I can see that this is direct variation, where 4 is my constant of variation. Oops. Okay, so here we have one. We're going to write an equation for inverse variation. And it tells me that the variables x and y vary inversely. So if they vary inversely, I know I'm going to start at y equals a, and if it's inversely, I divide by x. Then they give me some more pieces of information. They tell me that y is 7, I still don't know a, when x is 4. But knowing this information, I can go solve for a. So I'm going to multiply both sides by 4. Now I can rewrite my equation by plugging in the constant of variation. So there's their equation that relates x and y. The second part they want me to do now is to find y when x equals -2. So all I need to do is plug in -2 for x. Okay, word problems, our favorite. So MP3 players. The number of songs that can be stored on an MP3 player varies inversely with the average size of a song. A certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes. Write a model that gives the number n of songs that will fit on the MP3 player as a function of the average song size s. So they told me that n varies, so I have my constant of variation, inversely, so I'm going to divide with s. So there's my equation. Then it wants me let's solve for a, sorry, gotta solve for a. So then they gave me a piece of information. They said that a certain MP3 player can store this many songs, 2,500, when you have 4 megabytes. So plug that in. And solve for a. Alright, so now I can rewrite my equation with a plugged in. I'm going to just go right down here. Okay, next next one, it wants me to make a table showing the number of songs that will fit on the MP3 player if the average size of a song is 2 megabytes, 2.5 megabytes, 3 megabytes, and 5 megabytes. X and Y here we want. S and N. So I'm going to be plugging in 2, 2.5, 3, and 5. So when I plug 2 into this S, I get out 5,000. Plugging in 2.5, 4,000. When I plug in 3 and 5. Make sure you can do this. Check in your calculator that you get the same thing that I do. So what happens to the number of songs as the average song size increases? So as this gets bigger and bigger and bigger, what happens here? Hopefully you're thinking it's getting smaller, because it is. That's what inverse variation means, is one thing gets bigger, the other one gets smaller. So it varies inversely. Oops, that was for that last one. All right, I want you to try these on your own, and you can pause me here. And when you get to school tomorrow, you're going to check with your group members to see if you did them correctly. Joint variation. Now we're going to put a whole lot of things together that can vary. You can vary inversely, directly, and just put it all in one equation. You're still going to have your constant of variation A. So here I could say that Z varies, got my constant of variation. Jointly just means I'm going with X and Y. So I'm going to have X times Y, all of that together. Here you can see it varies jointly with Q, R, and S. So let's try this one. It says the variable Z varies jointly with X and Y. Do you think you could write that equation? Go ahead and try. So I have Z equals A. Jointly, so I'm going to keep going, X, Y. So I just write it all as a product. Then they gave me all that information that I get to plug in and solve for the constant of variation. So let's do that now. Make sure you can get 5 for your constant of variation. So your equation is Z equals 5 XY. So there's the equation part. Now let's go ahead and find Z when X equals 2 and Y equals 6. And I got 60. Hopefully you did too. Okay, so let's do A through E. Write an equation for the given relationship. See if you can get them. You can pause me, and then I'm going to fill them in. So Y varies, so I have Y equals A, is how I'm always going to start. Inversely now, so I divide by X. B, Z varies jointly, so Z varies, so I have Z equals A, that constant of variation. Jointly, so I'm going to keep multiplying with X, Y, and R. C says Y varies, so I have Y equals A. Inversely, so I'm going to divide with the square of X, not the square root, but the square would be X squared. And Z varies directly with Y. So Z varies, I got my Z equals A. Directly with Y, whoa, hold on, but now it's inversely with X. So I multiplied by the Y, but I have to divide by the x. And E, x varies jointly with T and R, and inversely with S. Okay, I hope you guys did good, and I will see you in class tomorrow with all your questions.